So we've got to explain why the spent fuel rods from a nuclear reactor are more radioactive after removal from the reactor than they were before they were used in the reactor. Alright, so let's jump across. So if you think about it, what we've got initially as our fuel rods is we've basically got uranium-238 and we've got uranium-235, where 235 being the fissile elements. And both of these actually are naturally occurring, and because they're naturally occurring, the likelihood is they're going to have very, very long half-lives, because they are still, despite the fact they're radioactive, they are still going to be pretty stable. And you don't have to know the numbers, but so you're aware, that one's about 4.5 billion years for a half-life, and I believe uranium-235 is about 700 million years for its half-life. So if you imagine, they're not very radioactive. What then happens is uranium-236 is formed, because what we basically do is we fire the neutron into uranium-235 and it gets absorbed. Now uranium-236 actually is still pretty damn stable as an isotope. It's got a half-life of about 23 million years. Again, don't have to know that number. But it's actually, once we fired the neutron in, it's actually a lot less stable, because it's got plus the kinetic energy of the neutron that's gone in there as well. So it's quite a bit less stable than that 23 million years half-life suggests, because it's got additional energy. Now the fission products, so once you've once you know the uranium-236 is actually fissioned, the fission products actually have much shorter half-lives. Therefore, they are much less stable. Therefore, they have a higher activity. Now, typically, these things have a half-life of, say, 100 to 200,000 years. Now again, you're not expected to know the numbers, and they actually emit a whole range of alpha, beta and gamma in terms of radioactive. So the question, explain why the spent fuel rods from a nuclear reactor are more radioactive after removal from the reactor than they were before. Well, before they were a lot more stable, they had very much longer half-lives, and afterwards the fission products have very much shorter half-lives, are less stable, and therefore have much higher activity. Therefore, they are very much more radioactive. Hope that makes sense. Thank you very much.